We're going to do 6, 2. Multiplying radical expressions. When you multiply two radicals together, they have to have the same root. The same root, okay? In other words, if I was going to multiply a cube root times a square root, I cannot do that. They have to both be cube roots, both be square roots, both be fourth roots in order to combine them into one multiplication, okay? All right, so let's go ahead and let's remember what our perfect squares are. So we're going to list our perfect squares so that we have them and that when we need to simplify, we can go back to this list and do them here. So 1 is a perfect square, but we don't need to worry about that. So let's start with the next one. 2 squared is 4. 3 squared is 9. 4 squared, 16. So you see the pattern, right? 25, 36, 49, 64. What's next? 81? 81, 100. Where do you want to stop? 121, 144. Okay, so you get the idea. We don't usually go up any higher than that. But we're going to need that when we're like simplifying the square root of 75. It's going to have a perfect square in there. We need to figure out which one. So it's nice to have a list. All right, our perfect cubes. Now, when you're doing perfect cubes, you have to totally change your mind to not think perfect squares anymore. And it's hard because you're so used to perfect squares. But now we're going to think about perfect cubes. So our perfect cubes would be 8. 3 cubed is 27. 4 cubed, 64. 5 cubed, 6 cubed. Ooh, bigger, much bigger. 6 cubed? Really? Is it 216? 216? You sure? 216? Okay. Yes. All right, I don't know anymore. All right, so you get the idea, and those are your perfect cubes. Most of the time, though, we stick kind of in these 3. We'll do those 3 most of the time. Sometimes we do 1,000, because 1,000 is just 10 cubed. All right, so here we go. We're going to do kind of 3 things. We're going to multiply, we're going to simplify, and then we're going to put them together and do another step. So the first ones are going to be stuff that you've kind of done before, and then some things that are a little bit new. So the first thing is we need to multiply these together. So rad 2 times rad 8. They are both square roots, so we can go ahead and combine that into rad 16. And the square root of 16 is 4. Nice. Ew, that's a terrible 4. Cam, your 4 was really good the other day, huh? All right. Now let's do cube root of -5 times the cube root of 25. They're both cube roots, so we can multiply, combine them together into one cube root. And that would be the cube root of -125. And you know that one? -5, yes. And if you're struggling and you're not sure how to take the cube root of -125, remember your calculator will do that for you if you need to. All right, the next one. The 4th root of -2 times the 4th root of 8 gives us the 4th root of -16. That's an even root, an even radical. And we're only doing real roots here, so this one would have no solution. Perfect.
Really good 3s.
Do you? Your 3s are good. Okay. And then finally, number 4, it's the cube root of 7 times the square root of 21. And I saw some people shaking their head, nope, because they're not the same roots, so you can't multiply them together. All right, so you're feeling pretty good? That's the first 4. Only like 19 more to go. All righty. Here we go, number 5. So now what we're going to do is we're going to do something you've already done before, which is to simplify the square root of 75. But now we're going to do it with variables that don't divide evenly. So last night you had problems like this, 25x squared, right? And you take the square root and you get 5x and life was beautiful. But what happens when it's not a perfect square and it's not a number that's nice and divisible? So let's see. Well, 75, square root of 75, you've done that already. You've simplified that. There is a perfect square in 75. What is it? 25. So 75 is 25 times 3. And what we do is we will take the square root of 25 and the square root of 3 separately. And we take the square root of 25, which is 5. And leave yourself a little blank here for a minute, and then put the 3 back in. So you've done that already. You should feel pretty good about that. That was last semester. Okay, now the x cubed, this one's a little tricky. This one is not a perfect square, but there is a perfect square in there. So there's 2 ways to do this. Let me teach you one way first. If we're trying to find the the square root of x cubed, you can break that up into something like that. Do you agree that x cubed is x squared times x? Yeah. Okay, and then what is the square root of x squared? It's x, and then the square root of x just stays under. Okay, that's one way to do it. When the numbers get a little bit bigger, you might not want to do it that way. What I like to do is this. The number on the outside is going to divide into the exponent. And what I do is I go 2 goes into 3 how many times? 1 with 1 remainder. So that means 1x comes out, 1 remains inside. I kind of like that. I don't know, do you like that? You like that easier? Yeah. So some people like to break it up into a perfect square times not perfect square. Some people just like to divide into the exponent, and that works every time. Okay? All right, let's do another one. Number 6. All right, so do the number part first, okay? This is the part that you're comfortable with, hopefully. 32. 32 has a perfect square in there. The biggest perfect square that goes into 32 is 16. So we're going to take the square root of 16 and the square root of 2. The square root of 16 is 4. 4 is going to come outside. What's it going to do with the 2 out here? It's going to multiply. Good. So we get 8 outside, and then that 2 stays back. All right, now let's do the number part. So now, or the exponent part, sorry. So now we have the square root of x to the 4th. This is what you did last night. This divides nice and evenly, right? 2 goes into 4 how many times? 2 times exactly, no remainders. So the square root of x to the 4th is x squared. Now see this 9 right here? That's not going to be a perfect square. So let's do it the new way, like the way that I like to do these. Let's go, 2 is going to go into 9. How many times does 2 go into 9? 4 times. And then how many remainders does it have? 1. So you're going to put 4 of the whole ones outside and leaving 1 remainder back. No? Some of you, yes. Okay, if you don't like that, you can split it up into y to the 8th times y to the 1. Then 2 goes into 8 4 times. That's this one right here. And that y stays back. That's the other way to look at it. Okay? I just like to divide. It just seems easier. Oh, and then that would be your answer right there. All right, number 7. You're trying to stay awake, huh? The struggle's real. I see it. Really? I don't know. We're switching gears here. In our mind, we cannot think perfect squares anymore. See that little 3 right there? We got to think perfect cubes. Perfect cubes. Okay? So is there a perfect cube in 80? Look at your list of perfect cubes. We wrote them down. Your list of perfect cubes. 8. I heard it. 8 times 10. Good. 8 times 10. Okay, so we're going to take the cube root of 8, which is 2, and then we're going to leave the cube root of 10 back behind. So you actually do the cube root of 8, this part right here, leave the cube root of 10 alone because there's no perfect cubes in there. All right, now we got to deal with the exponents. Okay, so use the division. You can take this index and divide it into your exponents. So here we go. 3 goes into 5 how many times? 1 time. Okay, 1x on the outside. And how many get left behind? 2. So x squared gets left behind. Okay, let's do it again. 3 goes into 6 how many times? 2. No left behinds there. Nobody gets left behind on that one. Dang it, I didn't leave myself enough room, did you?
No.
Dang. Okay. Now the last one, 3 goes into 7 how many times? 2 times. With how many remainders? 1 remainder. So z squared on the outside 2 times with 1 z left on the inside. I have some yeses out there, and I see some people going, no way. Yeah. This is abstract. It's difficult. It is. And then you're like, when am I going to use this in real life? No, you won't. Okay, number 8. Now we're going to combine them. Combine them together. Okay? We're going to multiply, and it's in that order. 1, multiply. 2, then simplify. Okay? So here we go. Are you ready? Let's multiply first. Multiply these. They're both square roots, so you're allowed to multiply. So what's 6 times 8? Do you know that one? 48. It's the one my kid always forgets. I'm like, it kind of rhymes, right? 6 times 8 is 48. I don't know. I just always remember that. All right, and then x cubed times x is x to the how many? 4. We add them. We add the exponents. This is why we needed to do that on that first day when we got back. And then y to the 5th. Okay, so you feel pretty comfortable in your skills of multiplication and adding exponents. Great. Now we have to simplify. So here comes the new stuff. Is there a perfect square in 48? Yeah, if you're struggling on that, just take your perfect squares and divide them into 48. It's going to be 16 times 3. Okay? So take the square root of 16, which is 4, and then leave the square root of 3 back behind. So that's not the new part today. That one I think most of you are very comfortable with. Now here comes the new part. There's a little pretend 2 right here because it's a square root. 2 goes into, we're dividing it into the exponents now. Exponents have their own rules that they go by. So 2 goes into 4 how many times? 2 times. Okay. And then 2 goes into 5 how many times? 2 times with 1 remaining. Are you feeling a little bit better?
Yeah.
Oh, he's out. You needed some coffee at break. Do you drink coffee? Oh. Okay. Maybe a soda? As they say out in Michigan, a pop? All right, number 9.
I'll give them some motivation.
Or a Red Bull. It'll give you... All right, number 9. Here we go. We're going to multiply first, and then we're going to simplify. So here we go. There's outside numbers this time. What do you think they're going to do? They're going to multiply together, yeah. So, did someone say divide? 3 times 2, 6. 3 times 2 is 6. Yeah, because they're on the outside, they multiply together. And then the insides will all multiply together. So 7 times 21 is 147. That's a big number. R to the 6s squared. Okay, so first start by multiplying it out. And now we're going to simplify it. So 147, that's a little tricky one. We haven't seen that one. But 147 is 49 times 3. Do you know how I knew that? I'll tell you a little trick. See this 7 right here? 21. How do you break that down into its factors? 7 times 3, right? So I knew I had 2 7s. So I knew it was going to be 49. Yeah, pretty good, huh? All right, so let's keep going. And if you didn't get that, then just ignore it. Okay. All right, square root of 49 and the square root of 3. So the square root of 49 is 7. And what's it going to do with the 6 out here? They're going to multiply. 6 times 7 is 42. Good. And then leave the 3 back. So that's just the number part. Now let's do the variables. 2 goes into 6. We're dividing into our exponents now. 2 goes into 6 how many times? 3. Oh, it's a square root. And then 2 goes into 2 1 time. And that's it. I didn't need that much. Nice. Yeah. Wow, really? Yeah. Remember, my rule is that if you need to go in the middle of class, you will take a tardy for that. Just so you know. And then if we're done with notes, then you can go afterwards. So
Hours short.
we just had breaks, so you gotta go potties during breaks. How much time do we have?
Yeah.
Uh,
I would potty during break time.
30 minutes, maybe? All right, let's go on. Number 10. No. Yes, number 10. Okay, cube roots. They're both cube roots. Let's go ahead and multiply them together. What is 54 times 5? I don't know. 5 times 4 is 20. I'm like, I don't know. What is that? 270. Yes, good. Man, I come from a calculator era. I need my calculator. 270. One of my former students, she posted on my wall or something. She said, "Remember when you said if you were ever stuck without a calculator and you knew you had to know how to do these?" She's like, "We fooled you. We all have calculators now at all times." And it's like a picture of her iPhone. It was cute. All right. X squared times x cubed is x to the 5th, and y cubed times y 4th is y to the 7th. Yeah. Don't forget we got to add. I know we get these properties mixed up. All right, so now let's go ahead and simplify. Are you ready? 270. Is there a perfect cube in 270? Yes, not perfect square, but perfect cubes. So look at your list of perfect cubes up above on your paper. 27, yes. You've been telling me that for like the last 10 minutes. All right, 27 times 10. All right, so here we go. Do you want to finish this? Yeah? Okay, you try it. Try to finish it, Samuel.
Samuel is,
What if you were Mr. Samuelson's son? You would be Samuel Samuelson. Wow. It's really weird. Kane woke up. Oh no, he's really laughing now. See if you got it. All right, so the cube root, we're going to do the number part first. The cube root of 27 is 3. And then 10 stays back because it's not a perfect cube. Now, 3 goes into 5. 1 full time with 2 remainders. 2 left over. And then 3 goes into 7. 2 full times with 1 remainder. Who got that? 1, 2, 3, 4, 5. About 12 kids got that. Okay. All right. There we go. Because they can't see, the video. Yeah.
For the, you know you have a 3 right side.
This one?
Yeah, do you have to write that?
Yes. Thank you. I'm so glad you asked that. There's a huge difference between the cube root of 10 and the square root of 10. And a lot of people, they forget that in there. But there's a big difference, right? Yeah.
On the test, this is gonna be like noticeable that that's not like 3 roots in.
Yeah. Is it not noticeable here?
Well, when you write
See this little tiny 3?
well, it's noticeable.
Yeah.
It's printed.
So we got
And then see that 2? That's a big 2. It's noticeable, yeah. Just, yeah. You can always ask me, do you mean, is this a 3 in front or is this a cube root? And I'll tell you. All right, number 11. Yeah.
on number 7.
Did I forget to do something?
On number 7, do we have to write it?
Oh, 7.
Yeah.
Yes, we did. I have it. Do you have yours? Yeah.
when you write it, like, it has to be inside that.
I know. It should be. The computer doesn't do it that way. It should be in here, right? But they put it like on top. So I know. I don't like that either. But I can't fix that. That's a Word document thing. Okay, or equation editor, I guess is what it's called. So let's move on. Here we go. Next one. This one's easier. So we'll take a little break from the hard ones. And we're just going to distribute and then simplify. Okay? So what's rad 3 times rad 3? Rad 9. We can fix that in a minute. And if you knew that was 3, you could write 3. That's okay. And then rad 3 times rad 15. Rad 45. All right, so let's fix these now. Square root of 9 is exactly 3. And then 45 is what? 9 times 5? So that would be 3 rad 5. And then those do not combine together. That would be your answer. A lot of people want to write 6 rad 5, but you can't. Because if this was 3 rad 5 plus 3 rad 5, that equals 6 rad 5. These are not like terms. This is 3, and it's being added to 3 times rad 5. It's not the same thing as this. These are not equal, this and this. All right, yes, we're to the back page. Let's do it. We're going to divide some radicals now. All right, same rule applies. If it's the same root, then you can put it together under one radical. Are you okay? Okay, so number 12. What we're going to do is we're going to put these under the same radical. That way we can divide. Okay? It's radical 50 divided by radical 2 is really the square root of 50 over 2. And what is 50 divided by 2? 25. And what is the square root of 25? 5. Perfect. Okay? Now, if you want to skip this step right here, you can. You don't have to write that down every time. You can know that rad 50 divided by rad 2 is rad 25. That's okay. Number 13. Cube root of 32 divided by the cube root of 4 is the cube root of 8. Yes. They're both the same radicals, so we can divide 32 by 4 and get 8, and that is equal to 2. Good job. All right, 14. Yeah, she's quick. Oh, me? I'm sorry. Was that too fast? Sorry. Sometimes I get so excited, about the math and stuff, I go really fast through it. Yeah. And if you ever need me to slow down, just ask or go back and redo something. I have no problem doing that. Yeah. So we did 32 divided by 4 is 8, and then the cube root of 8 is 2.
What was the answer? 12?
Oh, 12? 12 was 5.
5, right?
Yeah. All right, 14. 81 divided by negative 3. Negative 27? Yeah. Okay. So first divide.
Wait, so for number 13,
Yeah.
what about the whole, put it all in the same?
Yeah, you can. I've just been kind of skipping that step just because, you don't really need it if you know it in your head.
Oh,
I just went
32
straight there.
divided by 4 is 8.
Yeah.
Yeah.
It helps, yeah, to know your multiplication tables. All right, here we go. Cube root of negative 27 is negative 3. I tell my son all the time, you got to know these, and he's just like that. All right, and then 15. 15. Yes, and then keep going. Okay, here we go. 32 divided by 2 is 16. And then what's x cubed over x to the 1? It's x squared. We subtract our exponents, right? 3 minus 1 is 2. And then what is the square root of 16x squared? 4x. Good. Samuel, did you get that one? He says yes. Okay, here we go. Number 16. 16. Okay, now what we're going to do is we're going to do this in order. We're going to divide, and then we're going to simplify in that order. Okay, so do the division part first. You divide those right now. You do that part, and then I'll help you with the simplify part in just a minute. So divide those two, okay? Divide 24, m to the 4th, and 2m. Divide that and put it in one radical. Kane, put the iPad away. If Kane's mom's watching, he was on his iPad again. Shout out to Kane and his mom. Okay, 24 over 2 is 12. And m to the 4th over m is m cubed. Now, they're still inside of that square root, though. And now we have to simplify. Do you think you can simplify that? No, not yet? Some people said yes. Some people was like, no. So what's a perfect square in 12? 4. 4 times 3. So let's take the square root of 4 and leave the square root of 3 behind. Okay, so that's the number part. And now we're going to do 2 goes into 3. We're going to divide into our exponent. 2 goes into that 3 how many times? 1 time, 1 remainder. Are you getting the hang of these a little bit better? Yeah? Okay. 17. Wow, that looks like a lot, doesn't it? Don't forget to do these. Yeah. Okay, we're on 17 now. You just got back? So here we go. Divide. What's 162 divided by 3? 54, good. 54. And then what's p to the 5th over p squared? P to the 3rd, subtract your exponents, and then q squared. All right, so your first step is to divide. Divide the numbers, subtract the exponents. And now let's go ahead and simplify this. Is there a perfect cube in 54? Yeah? Okay, if you don't know, just get your calculator and start dividing by perfect cubes. 54 divided by 8. 54 divided by 27. Yay! 27 times 2. So 27 times 2. Cube root of 27 is 3. And then leave the cube root of 2 back behind. Don't forget that little 3, remember? Cube root of 2 back behind. Now do the variables. So let's go ahead and take the cube root of p cubed. That would be what? P. And then 3 doesn't go into 2. So that one is just left. Left alone. 3 can't go into 2, so you just leave it. And that would be your answer. We're getting there, people. We are. There's a light at the end of this dark algebra tunnel. Okay, here we go. 1024 divided by 4. 256. Yes. 256 x to the 14. Now, perfect fourths are hard. We didn't even talk about those, really. 256 is a perfect fourth. It actually is. Go to your calculator. Plug in 4. Fourth root of 256 is 4. Perfect. All right, so 4. Fourth root of 256 is 4. And then 4 is going to go into 14 now. 4 goes into 14. How many times does it go in? 3. Good. 3 times 4 is 12 with how many remainders? 2. So we write that in exponents. We write x to the third on the outside. 3 full ones came out. And then the fourth root of x squared left back behind. Nice. All right. Any questions so far? We're doing okay. Okay. And then the next 5, we're going to rationalize. Okay, we've done rationalizing this year. Number 19 will not be new to you. It's something we've already done. The rest of them are going to be a little bit new. Okay? When you rationalize, you want to simplify first if possible. Simplify first and then rationalize. Now, some of you guys are sitting there going, I don't know what rationalize means. Rationalize means that you cannot have a radical in the denominator of a fraction. We got to get rid of it somehow. Okay, and we can't just go, okay, it's gone. We have to use algebra rules to get rid of it. So do you remember how to get rid of that rad 3? We did this last semester. Yes, exactly, good. Multiply top and bottom by rad 3. It's called rationalizing. So rad 2 times rad 3 is rad 6. And rad 3 times rad 3 is rad 9, which is 3, exactly. And that's rationalized. These are exactly the same. Rad 2 divided by rad 3 is equal to rad 6 over 3. It's just now it's rationalized is what we call it. All right, so now we're going to do that, but we're going to put some letters with it. So my suggestion to you is to simplify first. Don't start doing rad 5xy top and bottom. There's an x up top and there's an x on the bottom. Simplify that first, okay? 3 minus 1 is rad x squared up top and rad 5y on the bottom. Do you see what I did? I just simplified it. I took all my x's together. And now I can simplify that because that's just simply x over rad 5y. So that is completely simplified. I can't do anything else with those things, but I need to rationalize now. So I'm going to multiply top and bottom by whatever the denominator is. So I need to multiply top and bottom by rad 5y. Okay, so what I get up top is I have x times rad 5y is just going to be x rad 5y. On the bottom, I get rad 5y times rad 5y, which is what? It's just 5y. Okay? If you don't know that, you can multiply them together and get 25y squared, but when you take the square root of that, it's just 5y. And that would be your simplified answer. Okay, 21. 21. This is a lot like the last one. First thing you want to do is simplify. 5 minus 2 is 3. Perfect. X cubed up top. Bless you. Rad 3y on the bottom. Can we still simplify this a little bit more? Yeah. See that x cubed right there? 2 goes into 3 one time with 1 remaining. And rad 3y doesn't change at all. Okay, now we're ready to rationalize. What do you think we're going to multiply both top and bottom of this fraction by? Yes! Someone whispered rad 3y. They were a little shy, but they had the right answer. Okay, so now let's multiply the top. And we get x, and then x times 3y is 3xy. And then on the bottom, rad 3y times rad 3y equals 3y. Okay. Now, if you've tuned me out so far, you might want to come back because these last two are the hardest two of the day. Woo, I know, last two. We're there. Okay, here we go. Cube roots. What are you watching, football? Oh, surfing?
No.
Okay. All right, cube root of 2 over the cube root of 3x. Now, there's nothing to simplify here, okay? There's no x's together, 2 and 3, those don't reduce at all. But we're going to need to multiply top and bottom by the cube root of something. Now, here's the thing. We think it's 3x, but it's not. Because if I multiply top and bottom by rad 3x, cube root of 3x, I will get the cube root of 9x squared. And that didn't fix anything. Because the cube root of 9 is ugly, and the 3 doesn't go into 2. So what should I multiply by? Anybody want to take a guess? What would give me a perfect cube?
Multiply by 9.
Yes. So if I did 3x times something, I want to get a perfect cube here. 9 times 3 will give me 27. That's a perfect cube. And what times x will give me a perfect cube? X squared. Okay, now do you see what that is? It's this whole thing right here, squared. I need 3 of them. I need 3 3's, and I need 3 x's. So I'm going to multiply top and bottom by the cube root of 9x squared. That's the hardest part for people because they're so used to just multiplying by exactly what you see. And that works for square roots, but it does not work for cube roots. All right, so let's do it. I get the cube root of 18x squared. And then on the bottom, we end up with the cube root of 27x cubed. What's the cube root of 27? 3. What's the cube root of x cubed? X. And that's your answer. Okay? It makes it so hard because you're so used to just doing the same thing, top and bottom, you know, as this one. But it doesn't work that way for cubes. All right, last one. And there's actually a shortcut on this one. You can, if you want to, simply square 4y squared and get that, and that'll be a perfect cube. But what else would make this a perfect cube? 4 times what gives me the smallest perfect cube besides 1? What is that? 8 is a perfect cube. And if I just did 4 times 2, won't I get 8? So let's do that. And then how many y's do I need to make it a perfect cube? Just 1, yeah. That'll give me 3 y's. Okay? All right, so let's do it. I get the cube root of 10y squared. And then I get the cube root of 8y cubed. And I can fix that. Not fix it, but simplify it. And what is the cube root of 8y cubed? 2y. Perfect.